Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function, and that is the revenue function. R is equal to 800x negative 0.2x squared, where x is the number of units produced and sold. We have to find the number of units that will maximize revenue. So we have to find what is x so that this R will have a max. Okay? So let me remind you what is the mathematical concept behind maximizing a function. So if you have a nice continuous function, say f, and it has a maximum value here. So that's the peak. So what is happening at that point? Notice that if you draw a tangent line to the graph of this function, that line is going to be horizontal. And therefore, any horizontal line has slope is 0. But do you remember what slope of a tangent line represent? That is exactly the derivative of the function. And so slope of tangent line 0 means the derivative is 0 at that point. So at a maximum point in a continuous graph, the derivative of the function is 0. So we can use that concept here to figure out when R will be maximum. So the first thing we have to do is compute the derivative dr dx. So this is d dx of this expression for R, which is 800x minus 0.2x squared. Now using the rules of derivatives we can apply here. This is nothing but, so derivative of 800x is 800 times 1 minus derivative of the second part is you write down the constant, and then d dx of x squared is just 2x. So simplify this a little bit. This is 800 minus 0.4x. That is the derivative of the revenue function. So using this concept now, we have to figure out where this is maximum. So we just set it equal to 0. Set the derivative equal to 0. And then solve. Okay, so here is our dr dx right here. So let's plug that in here. So we'll have 800 minus 0.4x is 0. And then we solve for x. So let's keep the 800 on the left side, take the 0.4x on the right, and then we divide by 0.4. So the right hand side, the 0.4 cancels, and we get x is equal to 800 times 10 over 4, and that is 2000. So let's think one more time what we're doing. We set the derivative of the function R equal to 0, and we get x equals 2000. Does it automatically means that 2000 unit has to be produced to maximize the revenue function? Is this really going to give us max? Now, yes, the question is to maximize, and we did get just one value for x. But please keep in mind that when a function has a minimum, it also has the exact same property. The derivative is 0 at that same point. So how do we know that this will be a maximum point and not a minimum point, for example? So let's go back to the original function for the revenue and carefully notice that this function is a quadratic expression, and therefore its graph will be a parabola. We know that. Okay, so this is a parabola. Further notice that this negative sign will ensure that the parabola is going to be opening downward for sure. So our R will look like a parabola, something like this. And therefore, whatever x value we got when we set the derivative equals to 0, will definitely give us a max. So dr dx equals 0 will definitely be the max and not the mean. And so our answer is that 2,000 units should be produced and sold to maximize revenue. Thank you.